All right, so for LU factorization, we mentioned yesterday we can rewrite A, which again is our coefficient matrix. You recall we have AX equal B. So in other words, you have 3x plus y plus z equals 5. X minus y minus z equal -1. And x minus y plus 6z is 6, I think. So what we have here, A, of course, is 3, 1, 1, 1, -1, -1, 1, -1, 6. That guy times x, y, z is equal to these guys, of course. Okay, so what we're going to do is we're going to take this fella here, and we're going to break him into two matrices. Okay, the L, which is the lower matrix, 1, 1, 1. So we'll have some numbers down here. Well, some non-zero numbers. We're going to have 0 up here. And we're going to have an upper matrix, or a U matrix, I should say, which is 1, 1, 1 numbers up here and zeros down here. You with me? And then we're going to take that guy, and it's going to be times x, y, z, of course. And of course, it's still going to be equal to 5, -1, 6, because what are we saying? We're saying that A is equal to L times U. Okay? Now, a couple things in this. This is, again, sometimes you're looking back at this and you're going, so, like, what the heck? Why are we doing this? Well, we're kind of showing you a glimpse into what we used to do a little bit. And I say we, not really me, people before my time, honestly. But we're also getting better at our matrices, seeing how things work with matrices, being able to function and follow along and do that sort of thing. So it's pretty straightforward, and it's honestly a pretty easy process. What I want you to see right here, this right here, we're going to look at this as this is L times, now check this out, x1 or something. Are you with me? Not just x anymore, but just like we'll call x1 is equal to b. Okay? What are you going to say then? Well, what you're saying is I'm going to solve for what this crap equals. You with me? We're going to solve for what this garbage is. Does that make sense? It's an in-between step. And then what we're left with is oh, well, that's interesting. So what we're saying then is that u times x is going to equal that x1 then. Is that right? Oops, not u. In other words, u times x, 1 rather, is going to equal, I'm sorry, u times x, which again, this is u times x, is going to equal some x1. You with me? And we're going to be able to solve for what these guys are. Those are the guys we want. So in this process, kind of keep in mind where we're going here is this is an in-between step. It's a way we used to do things. Okay, but it's also another way we're going to see we can take this same thing, we can rewrite our function A and do some kind of cool things with it later on. Okay, when I say cool is a relative term, of course. Okay, this is not big block Chevy making 750 horsepower cool. This is not an old, tractor from the 50s cool. This is, math cool, right? So, Jay, it's not very cool. Yeah, I get that. So, what we're going to do here is we're going to find our U matrix. So, remember, our U matrix is always, it is the REF. Okay, U is the REF, reduced echelon form. But now this is very critically important when you do this. Yes, you can get this REF a lot of different ways. Okay. For instance, on that top, so on this guy, if you ended up with 3, 1, 1 on the top row, that's totally fine. If the next row down is 0, 1, 5 or something, and the next row down is 0, 0, 2 or something, whatever, I could then go through and divide any of them by any constant that I want, and it's still reduced echelon form. Does that make sense? But for the purposes of what we're doing here, it is critically important that you always do, we're obviously going to find these guys here and here first, we're going to get zeros. And you're like, Jay, I'm going to do, and this is cool for you, you could do this to get to row echelon form. That is 100% fact. However, it must be done for what we're doing here backwards. So it's going to be R2 minus 1/3 R1. And ditto R3 minus 1/3 R1. It must be done in that fashion. Okay, that's all I got for you. It's got to be done that way. Okay, and so if I'm building this guy out here, I'm going to start off with this. And so obviously the top doesn't change. And so 3 minus, or it's going to be 1 minus 1 is 0. And then it's going to be negative 1 minus 1/3 is negative 4/3. And negative 4/3 again, I guess. Nice. And then the next one down is going to be, it's going to be 1 minus 1 is 0. And then it's going to be negative 4/3 again. That's pretty cute. And then it's going to be 6 minus 1/3, which is 5 2/3, which I think is 17/3. Okay, that's pretty slick. And then now we're going to want to do R3 minus R2. Okay, always going to write it that way. And so what we end up with is, if we hold our mouth right, 3, 1, 1, 0, negative 4/3, negative 4/3, 0, 0, and then 17 minus a minus 4 is 21/3, which is 7, by the way. You look an idiot writing it that way, Jay. There you go. This guy right here should be, theoretically, my U matrix. Theoretically, if I didn't screw it up. But who knows? Now, my L matrix, which is pretty straightforward, is literally boom, 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 boom. And then check it out, friends. It is 1/3, 1/3, 1. Now, it's always the first one minus the second one. So if you came up with a plus, it'd be minus a minus, obviously. But in our case, these are just straight minuses. And so it's going to be the positive value. Now, you're like, Jay, I don't believe you. Can you show me the multiplications? Gosh darn it, I'd love to. And so we're simply going to do this number, 1, 0, 0. 1/3, comma, 1, comma, oops, damn it, darn it, comma, 0, semicolon, and then 1/3, comma, 1, comma, 1, times, and then it's 3, comma, 1, comma, 1, 0, comma, negative 4/3, comma, negative 4/3, semicolon, 0, comma, 0, comma, 7. Hey! Oh! No way! Now, no way! Oops, that's the wrong button. Where'd it go? Oh, it's the same guy. Gosh, I hope so. That was the whole point. Are you with me? Ba-boom! Now, check this out. This is exciting. And then we're going to say, obviously, times x, y, z, ba-boom, ba-boom, ba-doom, equals 5, negative 1, 6. Now, by the way, nothing was hurt. That was an easy process. Are you with me? That's money. I mean, it's not hard. Now, here's what's fun. We're going to call all of this x1, y1, z1. Are you with me? So if you look at this, it's going to say, well, if you take this 1, 0, 0 times this vector here, you're going to get x1 equals 5. And then you're going to get 1/3 x1 plus y1 is going to equal negative 1. Again, that's this row, this column. And then you're going to get 1/3 x1 plus y1 plus z1 equals 6. Well, that's pretty cool. And so, well, there it is. So if you plug 5 into there, you're going to get 5/3 plus y1 equal negative 1. And so y1 is going to equal negative 8/3, I believe. Okay, cool. So you plug it back in, you're going to get 5/3 minus 8/3 plus z1 is equal to 6. And so that's 5/3 minus 8/3 is negative 1. So z1 is equal to 7, apparently. Okay, is that my final answer? No, goodness no. Heavens no. No. We just solved for what this product is. So what we're really saying is that 3x plus y plus z is equal to 5. We are saying that negative 4/3 y minus 4/3 z is equal to, what did we say y1 was? We said it was equal to, oops, is equal to negative 8/3. And we are saying that Z1, oh, by the way, we're saying, oh, I'm sorry, back to train fluid. What we're saying is that we're saying that 7Z is equal to Z1, which of course is 7. So what does that tell me? Well, it tells me that Z is equal to 1. Okay? And so if you plug that in, you get negative 4/3 Y minus 4/3 equals negative 8/3. So if you plus this over to here, you're going to get negative 4/3 is equal to negative 4/3 Y. So Y is equal to 1. Oh, we'll plug this and this into here, and you're going to get 3x is equal to 3. So x is equal to 1. So 1, 1, 1 is your final answer. Notice that they didn't do a lot of heavy lifting there. Okay. In fact, I did a pittance amount of algebra. Okay. Now, again, in the age of calculators, it's kind of a waste of my time. Well, I'm not going to argue that. But again, it's getting comfortable with matrices, just getting comfortable with matrix operations. That's why I still teach it to some degree. And there's one other spot where it kind of comes in handy, but we'll do another one here. Okay. So, oops, clear. There you go. Now, suppose you have this fella here. I'm just going to make my own because I can. So 2x minus y plus 3z equals 7. And 4. Ta-da! Nice. So again, our A matrix is 2, negative 1, 3. Oops. And what are we doing here? We're going to take this guy. Of course, we're going to multiply it through by, x, y, z. And of course, our answer is going to be 7, 1, 4. 1, 1, negative 1, 7, 6. And we're going to reduce this fella. Oh, no. Okay, so we are going to take R2 minus a half of an R1. And we're going to do R3 plus a half of an R1. Okay? And so when we do that, we will get ba-boom, ba-boom. So 2, negative 1, 3. And then the second row down, it's going to be 1 minus 2. 1 minus 1 is 0. And then you're going to have 1 minus a half, so 3 halves. And then you're going to have negative 1 minus 3 halves is negative 5 halves, I believe. And then the third row, it's negative 1 plus 1 is 0. And you're going to have 7 plus a half, or 7 minus a half, rather. So it's 6 and a half, so 13 halves. And then 6 plus 3 halves is 15 halves, I think. Okay, that's cute. Now I need this fella here to go to 0, of course, obviously. And so you're going to take R3. What you're going to do is you're going to say, all right, well, cool. So I'm going to have 13 halves minus 3 halves times something, right? Needs to equal 0, right? That's the idea. Or another way of saying that would be that 3 halves, okay, so 13 halves has to equal 3 halves times something, yes? And so then if you do this, if you divide, well, it's going to be timesing by 2/3, you're going to get to A would be 13/3. So what I need to do is I need to take and go, all right, I need to do R3 minus 13/3 R2. Got me? And so, again, this is not one that I can just do off the top of my head. Well, kind of I can, but it's hard. 0, 3 halves, negative 5 halves, 0, 0. Better be 0. We're screwed. And then, of course, 13/3 times 15. Oops. Darn it. You dumb idiot. It's going to be 15 halves minus, right, 13/3 times negative 5 halves. And I get 55/3, of course, obviously. There it is, baby. So there's your U. No, it's not a vector. Quit writing vector. It's a U matrix. Ta-da! And then we need our L matrix. Again, our L is easy. It's 1, 1, 0, 0, 0, 0. There it is. And then you're going to have negative a half, or you're going to have positive a half, negative a half, and then 13 thirds. If all is right in the world, this will equal what we started with. So let's check it real quick. Remember, matrix multiplication is not commutative, so don't try to do it backwards. You'll not work. Oops, comma 1. And that should be what I started with. Let's double check that that's true. Come on, Jay, get up there. 2. Where'd I go? 2, negative 1, 3, 1, 1, negative 1, negative 1, 7, 6. That's perfect, baby. Perfecto. So x, y, z is equal to 7, 1, and 4. Cool. And again, this right here is going to be x1, y1, z1. You with me? That's our in-between variables. So it's going to be 1 times this guy. So it's going to be x1 is equal to 7. And then it's a half of an x1 plus a y1 is equal to 1. Negative a half x1 plus 13 thirds y1 plus z1 equal 4. That's cool. So if you plug it in, you're going to get 7 halves plus y1 equals 1, which is 2 halves. So y1 is negative 5 halves. And then if you plug them in, you're going to get negative 7 halves. Okay, and let's get a calculator out. It's too much work. It's too much work this time of night. So solve. And so negative 3.5 plus minus 65 sixths plus z, sure, why not, equal 4, comma z. So z is 18 and a third. 18 and a third is what? 55 thirds. Oh yeah, how about that? Z is 55. Z1 is 55 thirds. Weird. Is that going to happen? So check it out. So we just solved for this garbage. So we're saying that 2x minus y plus 3z is equal to, what did we say the first one was? 7. Because that's what x1 was. And then we're going to say that 3 halves y minus 5 halves z is equal to, y1, which is negative 5 halves. And then you're going to have 55 thirds. Z is equal to 55 thirds. So z is equal to 1. Well, if z is 1, then 3 halves y minus 5 halves equals negative 5 halves. Hey, y is 0. That's good. That's what it's supposed to be. And then 2x plus 0, obviously, plus 3 equals 7. So x is equal to 2. Ta-da! And again, 2, 0, 1 is the answer I was shooting for. So that is how you do your LU factorizations. Okay? Now I'm going to pause you for a sec while I get set up for the next part of it here. Okay, the last thing we talk about is this. What would happen if you had a situation like this? So you're like, I want to do an LU factorization on this guy. Sure. But let's say, hypothetically, you have, I don't know, 4y minus z equals 3. And you have x plus 2y plus z equals 12. And then so negative 2, I believe. Okay? So if you have this guy, so your A matrix becomes this fella. Right? And you're like, oh, cool, I want to do reduce row echelon form. Well, you can want one end and, on the other. But listen, here's the deal. That ain't going to work. Because you need to do what? Well, you need to transform this. You need to at least put one of these guys on top, right? You can't have that one there. And so when you think about this, how do we do that? Well, we talked last time about, listen, well, you can take the identity matrix. And of course, if you take this identity matrix, which is an elementary matrix, right? We talked about that as well. And we said, listen, what can you do with elementary matrices? Well, you can, if you want to, do this. 0, 1, 0. And what am I saying? 0, 1, 0. And, no, 0, what am I thinking? 0, 1, 0. And then 1, 0, 0, and 0, 0, 1. What would happen if you took this fella here times this guy? What would happen? Well, let's find out. So you take that first row times the first column, and what are you going to be given? Well, when you do that, it's pretty straightforward. You're going to go, well, 0 times 0, 1 times 1, 0 times 4. You're going to get 1. On the middle row, you're going to get 0 times 4, right? And then 1 times 2, and then 0 times negative 1. You're going to get 2. And then, again, on the far row, you're going to get 0 times negative 1, 1 times 1. And then, of course, there it is. Now, on the second row down, you're going to get 0, 4, negative 1. And then, of course, the bottom row doesn't change. And that's it. What have we done here? Well, effectively, what we're saying is that we're saying this, all we did was we transformed it. Now, this, when it comes to an LU factorization, we are tweaking it to make it so it works out. The way we're doing this, we're going to take what's called a permutation matrix. A permutation matrix. Okay, and so when we do this thing, pretty straightforward. P is our permutation matrix. There it is. Okay, and so what we end up doing is we end up taking P transpose. There's our guy, so we write it. So we say PT of LU, like so. That is equal to our A, in other words. Okay, and so when I say that, here we go. So I cannot do a LU factorization matrix until I rewrite it in a way that makes sense to us, okay? And so that's how it's going to go there. And I will kind of walk through one here with you in a second, okay? It's pretty easy to do. You're going to see what I mean by that in a moment. Now, can we do more than one rearranging of things? Absolutely we can. Okay, absolutely we can. We can do things to our heart's content. Whatever makes us happy whatever makes me happy makes you happy, okay? Something else I want to get carried away before I do all that, though, is this. What would happen if you took this guy? So let's say we did that 0, 1, 0, 0, 0, 1, 1, 0, 0, okay? If you did that guy, okay? I shouldn't have done that way. No, sorry, let's back it up. Let's back the train up here. Let's say I want to do 2 rows. In order to do 2 rows, you'd have to do 2 different transformations. So on the first one, we did this one, on the last one like this. What? We just swapped the first 2. Now, but let's say I really want to put this one clear on the bottom too. I want to flip the bottom ones around too. What I can do is actually multiply that guy like so. So I can do 2 of them back to back. Okay, and you're like, well, what's that going to do to us? Oh, I don't know. Let's see what happens. Now, it's pretty straightforward, I think. If you're kind of half-assed paying attention, I think it's pretty straightforward. So first row, first column, what are you going to get? 0. You with me? First row, second column. Listen, you're taking 0, 1, 0. 1 is times by this middle row, by this middle guy, right? Every time it's going away on this one, 0. And then the last one's going to give you a 1. Okay? And so, all right, cool. There's that. Now, what just happened? Something's a little screwy there. All right, whatever. Hang on to that thought. Hold on to that. So then the next one down is going to be 0, 0, 0, 0. Beautiful. And the next one down is going to be 1, 0. And then the next row is going to be 0 times 0, 0, 0, 1. And so the bottom one has to be this. Okay, so what have I done? Okay, well, I've moved the top row officially to the bottom. Okay, and I ended up with the top row apparently on top, which is not what I thought I was doing. Hold that thought one moment. I'm going to pause you. I made a boo-boo. Yeah, actually, I didn't really mess anything up. I kind of did, but I want to do something. I was going to finish this problem here. So on this problem, all I needed to do was get that top one off the top row. Are you with me? That's all I needed. So I did that. Yay. Now, can I also move more than one if I wanted to? Sure. Yeah, obviously, right? That's easy. I can totally do that. And some of you are going, Jay, wouldn't it be cool if I also switched row 1 and row 3? Sure, I guess, if you wanted to. And to do that, what would you do? Well, you would multiply by what? Well, you want your top row now to be the bottom row, so 0, 0, 1. The middle row, you're just going to leave alone, right? And then the bottom row, you're going to want to have as what? You're going to want to have it as 1, 0, 0, right? This is a situation here. So then if you do that again, and by the way, what is this guy here? This guy is, we'll call this P1 times A, right? Our initial A value. That makes sense? So this is P1A. And so then what is this going to be? I guess P2. You with me? It's just a second transformation. It's a permutation, we call it. And so if I do this, 1, 2, 1, 0, 4, negative 1, 4, negative 1, negative 1. If you do this, it's 0 times this guy here. So 0 times 0 plus 0 times 0 plus 1 times 4. So 4 is going to end up on top. I hope so. That was the whole point. Same thing. Neg 1, negative 1. Middle row is going to be 0 times 1 is 0. 1 times 0 is 0. And then 0 times 0 is 0. So that's cool. And then 0 times 2, 1 times 4, 0 times 4, and negative 1. And then the next one is going to be 1 times 1, and then 0, 0. So 1, and then it's going to be 1 times 2, and then 0, 0, and then 1. So we've just moved it around. You're like, well, why did you do that? Well, I don't know. It seemed like a cool thing to do because now to get this 0 here, what are you going to do? So if you're playing along at home, we did P2 times P1 times A. Is that so far so bueno? So far so bueno. So what we're going to do now is actually then do our factorization here. Okay, that's cool. Here we go. So it's going to be R 3 rather minus 1/4 R 1. And you're going, Jay, you should have left it the way you did before. I could have. And will I get the same? No. Will I get a similar? Yes. Right? It won't be the same because I would have done it differently. Correct? And so if I'm playing along, making my thing here, I'm going to make my U first. So it's 4, negative 1, negative 1, 0, 4, negative 1, 0, I hope. And then it's going to be 2 minus a minus a quarter. So that's 2 1/4, which is 9/4. And I wish I would have thought that through a little bit, but life goes on. So 1 minus a minus a quarter is 1 1/4, which is 5/4. And that's a 4 right there, just in case you're wondering. And so then what I need to do is I need to take 9/4 minus 4 times something. Yes, in other words, 9/4 needs to equal 4 times something. And so it's 9/16 actually, by the way, right? So I need to do row 3 minus 9/16 R2. Okay? And so that gives me 4, negative 1, negative 1, 0, 4, negative 1, 0, 0. And then, of course, here we go. It's 5/4 minus, that's actually going to be plus 9/16. Well, this is 20/16, so it's going to be 29/16, I think. Those are ugly. You're not wrong, right? You are not wrong. And then over here, what would our factors be? Well, our factors, again, would be 1, 1, 0, 0, 0, 0. And then what did we do? Well, we didn't put anything there, so 0. And this was 1/4, and this was 9/16. Okay? And so then the question is, well, okay, so does that get me where I wanted to be? Okay? Probably. And so if we do this, let's see what happens here. So if I do that, if I go, so let's just see what happens. You know, hey, I just work here. You get that. Hey, is that what I started with? Is that what I started with? 411. Oh, what's the 411, man? Oh, it is. Well, it kind of is. Are you with me? It kind of is. And you're like, well, what happens? I need to get back to full on A. Are you with me? I need to get back to full A. And so if you think about this, so that puts me back to, what do I have? It puts me back to 4, 1, 1, 4, 1, 4, negative 1, negative 1, and 0, 4, negative 1, and 1, 2, 1. Okay? And so that is an A. That's A after it's been transposed. Are you with me? And so the question is then, well, wait, what? How do I get back to where I started from? Well, this is L, U, and I need to now multiply it by what's going to take me back. Okay? What's going to take me back? Well, we multiplied it by, what we did, we called it P2 times P1 or whatever, if you will, right? Those were our two things we multiplied by. We're just going to call this our P matrix, right? Well, what I need to do is I need to find the inverse of P, right? Or P inverse, if that makes you happy, it makes me happier. But if it doesn't make you happy, it's P prime. Then how does that work? Well, it turns out that P prime for these permutation matrices is always the transpose of it. So if you look up here, we didn't do it actually. We need to write out, we need to take this guy times this guy. This guy times this, actually this guy, I should say, the second one times that one. And so what I'm going to do is I'm going to take this guy, so 0, 0, 1, 0, 1, 0, 1, 0, 0, times 0, 1, 0, 1, 0, 0, 0, 0, 1. Oops, what did I do? What did you do, you dumb hippie? 1, 0, 0. I forgot a 0 somewhere. Yeah, perfect. That's what it was. That's what I ended up multiplying by, yes? Because what did I do? I put my bottom row in the very top. I put my top row in the middle. I put my middle row on the bottom. Yes, that's what I ended up doing. That is 100% correct. Well, to get back to A, though, this is exciting. Okay, to get back to A, I need to do the opposite of that. I need to put them back where they came from. So it turns out that the inverse of P is the transpose of P. So here is my P. My P is the bottom row. It is the middle row. Third row. What? Yes. And then this row. Yes? This is exciting. Are you ready for it? Are you ready for it? Are you ready for it? If this is P, yes, then its inverse is simply its transpose. And so its rows become its columns. Oops, I'm sorry. It was rows, rather. Its rows become its columns. Okay? Makes sense? Well, hold that thought for a minute. Okay? So if I take that guy right there, and if I cross my fingers and hope for the best, so I take that, well, actually, it's this guy right here, and transpose it, times this guy, I get that guy. You shut your mouth. You shut up. Look at that. Look at it. Look at it. 0, 4, negative 1. 1, 2, 1, 4, negative 1, 1. And so what this is often referred to as is P transpose LU equal A. Okay? And so when we do this, you could do this. You could do LU is equal to P times A. That's what we did. We moved rows in A, yes? And what we ended up doing was, okay, cool, we did that. So we took the top row, put in the bottom, and whatever, yes? Then we did the factorization of that. And then what we did was we said, listen, I want to solve for A. Well, what do? Well, to get rid of P, what do? You multiply by his inverse. And what is his inverse? Well, P Transpose is the inverse of the permutation matrix. But if I do it on that side, the cardinal rule of algebra says whatever thou doest to one side, thou must also doest to the other side. And what happens when you multiply these times these, you get the identity matrix times A, or in other words, just A, is equal to this fella. And that's all there is to it. It's a piece of cake. It's a piece of cake. Okay? Please don't stress too hard about that. It's not that bad, I promise. I went to a meeting today where this lady kept doing the really, and it was freaking me out. Okay, but I'm going to do another nice, straightforward one, I think. I'm just going to make up my own because I feel like it. Here we go. So we'll do a nice, simple one here. 2, 4, 4. Well, no, don't do that. Don't do that. Okay. Now it's totally up to you how you go about this. It is 100% up to you. No, darn it, I messed that up. Whatever. It's totally up to you how you want to do it. This one here, I could leave it alone. I could move it. I could do whatever makes me happy. Say these two were messed around. Let's say this was 204 here and this was 042. You're kind of screwed here because you need a 1 here, and that's going to be hard to pull off. So this one's got to move. You're like, I want to put it on the very bottom. Okay, that's fine if you want to. This one's got a 0 in the middle. I don't like it. Well, hold tight because in a minute we're probably going to be adding stuff and it might go away. But you're like, man, these would be really cool to flip-flop these two, right? We could just literally flip-flop those two. So your P matrix this time might be just to take the second row and put it on top. You with me? That's all we're doing. Leave the bottom row alone. So if I take this guy times my A matrix, which is 0, 4, 2, 2, 0, 4, 2, 6, 1, what I will end up with is, again, this is P times A. I will end up with, okay, so that says take this row times this column, yes, and all you're going to get is a 2. And then the next one over, you're going to get just a 0. And the next one over, you're going to get just a 4, because that's the middle row, yes? On the next, this guy times this guy, you're going to get a 0. And then you're going to get a 4. And then you're going to get a 2. And on the bottom row, you're just going to get 2, 6, 1. Okay? So this is PA. What I'm going to do now is I'm going to find the LU factorization of PA. Okay? I don't know why I wrote that again. I'm not going to write it again. So when I do this, it's really easy because I already got a 0 there. So it's just going to be R3 minus R1. And so that's going to give me 2, 0, 4, 0, 4, 2. And then 0, 6 minus 0 is 6. 1 minus 4 is negative 3. So I'm going to take now 3, R3 rather, minus 3 halves of an R2. And so that's going to give me 2, 0, 4, 0, 4, 2, 0, 0. Yes, and then we had negative 3 halves minus 3 is negative 3, I should say. Negative 3 minus 3 is negative 6. So that should be our guy, right? This is the L, this is the U part of the thing. And so when I do that, the L part of it, the L and the U part, right? Oh, God darn, they're not vectors, dummy. This guy becomes 1, 1, 1, 0, 0, 0. And then this is going to become 0. We didn't do anything there. That's going to be 1, and this is going to be 3 halves. Again, I'm just going to try this, see if it works out. If it does, yay. If it doesn't, I'm going to stop before I make a god-awful mess. So 1, 0, 0. 0, 1, 0. So you multiply it back out, you get exactly where you came from. Exactly where you came from, yes? So I'm back to exactly that. So what I have here, this LU is equal to our P. Why is this not working? Oh, poop. Is equal to our P, which we said was 0, 1, 0. 1, 0, 0, 0, 0, 0 times our A, which is 0, 4, 2, 2, 0, 4, 2, 6, 1. All right, that's P times A. And of course, this is PA over here, which is, we just traded those rows, 2, 0, 4, 0, 4, 2, 2, 6, 1. Okay? Okay, now, listen, I want to solve for frickin' A. So again, to solve for A, you've got LU is equal to PA. I want to do P prime, but P prime is really P transpose. And there it is. Okay, so what I'm going to do is, okay, all right, there it is. So if I just put out my transpose, here's this fella. What is his transpose? Well, the rows rather, become the columns. 0, 0, 1. Okay? So if you do this times this times this, you will get back to actual A. Okay? So I'm going to do that. So parentheses, or brackets rather, 0, 1, 0, semicolon, 0, 0, semicolon, oops, semicolon, 0, 0, 1, times this guy. And lo and behold, it's back where we started from. Ching! And that's it, my friends. 3.4 in a little bow. How exciting for us.